So the conic sections are formed by slicing a cone. And on your journal, number 6 asks you to draw a diagram and show how you get each conic section by slicing. So I'm going to show you with my actual 3D cone here as well as on the board. If you take the cone and you slice it straight across, just straight across, what shape will the slice be? Circle. Yeah, the part I'm showing you, what shape is that? It's a circle. When you slice through it, the slice shape is a circle. So we always get a circle if you slice horizontally across a cone. Okay. Well, so circles are one of the conic sections. There's 4 conic sections. So if I do another cone here, and hopefully get a circle in it, this time I want to slice diagonally. I want to go through one side and out the other. So I would be doing a cut like that. Okay, I got to vote for an oval. So if this one, when you slice through it that way, yes. In layman's terms, it's an oval. In mathematical terms, it's an ellipse, not an eclipse. There's no C in it. Okay? It's an ellipse. Okay. Next one, if I want to slice, this time I want to slice through a side and out the bottom, but this slice is always parallel to the edge of the cone, so I have to be doing a parallel slice here. It's parallel to the edge of the cone. What shape will that get? On here, on this cone, it slices through here and out the bottom. Have you seen that shape before? You just took a test about it. It's a parabola. So parabolas are parallel to the side, but they have to go through the bottom. Then last but not least, this one takes a little visualizing here. You have to have 2 cones to get the last one. And they are tip to tip. So they are going, we have one going upward and one going downward. Yeah, I should have just made it X. It would have been easier. So I'm going to have a cone on the bottom. Okay, this one's too long. I'm going to have a cone on the top. We'll erase part of that. They're supposed to be the exact same size cone. I didn't do so good. Okay, if you on these, you slice straight vertically through both of them. So my slice is going to go through both cones. They call that both naps of the cone if you have a top and a bottom. Okay, well obviously I don't have 2 cones here to do with it. But when I slice vertically straight through, I get a piece this shape, which kind of looks like what? It kind of looks like a parabola, but it's actually not. It's the curve is a little more sharp. It's a square corner that's been rounded off. But if I take my parabola shape, it's like having 2 slices back to back. So it's having 2 back-to-back curves gives you a hyperbola. Now I will also be talking to you about all the real-world uses of these, because believe me, without these conic sections, there are many things you all enjoy that you wouldn't have if you didn't have a conic section. You will have a very boring weekend if you're a sports watcher if you don't have conic sections, because your satellite dish is one of the conic sections. And the way your satellite works is key to one of these conic sections. Okay, today we are trying to do the 2 short, easy ones, circles and parabolas. I'm not doing tons with parabolas because we just spent a lot of time on parabolas already. Oh, sorry, didn't write the name. Sorry. It is a hyperbola, except I'm still online. Now, you notice in English you have hyperbole. This is hyperbola. You haven't done hyperbole? Last class said, oh, hyperbole, like they done in English. Hyperbole is an exaggeration, something carried too far. We'll discover that that definition has something to do with a hyperbola as well once you see the graph of it. Okay, there are a few, couple of formulas you learned back in Algebra 1, though, that you're going to find helpful through this section. You want to put these on your card. These are just general formulas that are helpful with all the conic sections. That's fine. Or just write their name. The first one I want you to remember is you remember the fun, exciting distance formula. Okay, when it found the distance of what? How far between 2 points, 2 sets of coordinates. If you have 2 coordinates, it finds you the distance between those 2 sets of coordinates. Anybody remember it?
G equals square root of, is it x minus x?
Yep, it's x minus x.
Squared.
Plus.
1x minus 3.
Yes. So does it matter which order you subtract the x's and the y's in? Okay. Normally we say they have to be done in the same order like with slope, but in this case, since you're squaring them, and the squaring gets rid of positives and negatives, it actually doesn't matter. You can subtract the x's in one order and the y's in the other, and it will still work since you're going to square it. So that's if you want to know distance between any 2 points they give you. Occasionally, everything we're going to do is going to be working with coordinates, and you may need to know the length of something. Distance formula will get you that length. Now, do I need to do an example distance formula problem to remember how to do those? It mostly knows. Usually distance formula is not a problem, other than knowing it, but it's on your card. The other formula you're going to use occasionally, you need to find the middle of 2 points, so you're going to be doing the midpoint formula. Now, this is one you actually shouldn't even have to think of as a formula. This is pure common sense. If I gave you 7 and 13 and I said, find the middle of 7 and 13, how do you find the middle of two numbers? 7 plus 13 divided by 2, you add them together and divide by 2. You're doing an average, or mathematically you're doing the mean. Well, that's all you're doing in the midpoint formula. We write it out as a formula, but all it says is add the x coordinates together and divide by 2. So it's nothing more than averaging your x coordinates and averaging your y coordinates. That's all it takes. So yeah, you can write it as a formula, but it really is common sense. Just add them together and divide by 2 if you want the middle. So that's the basics. Off to the land of circles. Now, a few people last class did remember doing this in geometry. You should have done it in geometry. Circles, there's really only 2 things you have to know in order to deal with a circle. What are the most important things to know about circles? The radius, which the diameter is just the radius doubled. But if you're wanting to locate it on a graph, what else would you need to know?
Center point.
Center, yeah. So with circles, all we really care about is where's the center, where's the radius. That's the 2 things we're going to be after. Okay. All of these conic sections have a technical definition in terms of how you define them on a coordinate system. I'm going to write these out. I think these are on your journal as well. Don't remember the number. They might. Do you have a set of questions that says the set of points? Yeah. Yep, that's where these go. So a circle is a set of points equidistant, and some of them seem bugged by that word equidistant last block. Equidistant means what? An equal distance from a given point. and just to get across why that makes sense, I'm going to put a point up here. And if I said to you, find me all the points that are 6 inches from that point, how would you find all the points that are 6 inches from that one? I could literally take my ruler here and go, okay, there's a point that's 6 inches away. But I could go up here at an angle and go, oh, there's one that's 6 inches away. And I could come over here and do, there's one that's 6 inches away. I'm up in my writing though. And I could come down here somewhere and say, hey, there's a 6-inch one. What am I going to get if I did all the possible points? Am I going to get a circle? Because that would be all the points that are 6 inches from that center point. So yes, let me give myself one more. I'm horrible at drawing circles. So we'll see if I can hit some points here. Oops, that went bad on that one. Okay, bad circle. Too lopsided up there. Did I measure that one wrong? That looks really wacky. That was off. I give. I'm horrible at circles. I should have used the circle tool. I could cheat. I should have cheated. That's really, really terrible. Go back. All right. We'll cheat. Better yet, I actually do have a circle tool. Woohoo! There, that's better. That's way better. Okay. Isn't it nice? Look at that lovely, beautiful circle. Okay, so yes, all the points equidistant from a given point are a circle. Not a big surprise. Anybody remember learning what the equation of a circle looks like? Actually, this is called standard form for a circle. Once I started writing it last block, somebody remembered. Do you remember an x minus h quantity squared? Plus, there was another quantity squared.
Does that something to do with the k?
Yes, it did. It had a k. It goes minus k. And it's y, yep, minus k, equals r squared. Now, yes, that should be on, yes. This standard form and the next two things I'm about to write should be on your card, yes. So, the two things we want to find out about our circle, if it's in standard form, you can just read the center out of it right now. And I'll give you a hint. It works the same way as the vertex of a parabola. H and K, yes. You just take it out of the quantity squared, and you'll have the center. Okay. Big hint. What part of that probably has something to do with the radius? You got another equal side of the equal sign. If that's r squared, that's saying the radius squared. Literally, that's giving you the radius squared. So whatever number they put there, what do you need to do to it to get the radius? You're going to have square root it, yeah. So you're going to have to do square root of whatever they have written as r squared, and that will always give you your radius. So in other words, it's just whatever r is. So circles, if they give them to you in standard form, are really easy. Suppose I gave you, no, we aren't going to freeze. Well, maybe we are going to freeze. Okay, it's a good time to stop the recording, and I'll unfreeze it.